Experimental Behavior of Laced Reinforced Concrete Beams Under Static Loading, published by International Journal of Science and Research IJSR, presented by Dr. Haifa Damed Hassan Al-Aboudi, researcher and designer at the Ministry of Science and Technology, Iraq, Baghdad. The aim of this research: investigate the effect of the lacing reinforcement on the behavior of reinforced concrete beam under static loading with different parameters such as diameter of lacing bar, 4, 6, and 8 mm, angle of lacing 30, 45, and 60 degree with beam axis, and lacing steel ratio. To compare the control beams and laced reinforced concrete beams to study the effect of the previous parameter on the behavior of laced reinforced concrete beams under static loading. To compare the response of the laced reinforced concrete beams between themselves with the changing the above parameter under static loading. The advantage of using lacing reinforcement technique in structural elements: full development of strain hardening zone and ductility of the flexural reinforcement, maintains of concrete integrity between the flexural reinforcement layers despite a lot of cracking, limited fragmentation after yield range, restriction of compression reinforcement from buckling, high shear resistance rather than the conventional syrup in reinforced concrete elements under transient blast loading. Linking the two principal reinforcement mesh together leads to improve the performance of laced reinforced concrete beams in the large deflection zone. The lacing shear reinforcement was considered an alternative to traditional stirrup in concrete structural elements to reduce diagonal shear cracks and flexural shear cracks. The laced reinforced concrete elements. Laced reinforced concrete elements contain an equal steel reinforcement on both faces, tension and compression, and tied by cross rod with a continuous inclined shear reinforcement, which has a role in transferring force and holding the lacing in position as shown in Figure 1. The experimental work. The experimental part is composed of 12 simply supported reinforced concrete beams of a cross-section 0.16 meter width, multiply 0.3 meter height and length 3 meter, with a vertical and lacing shear reinforcement. Two beams with a vertical shear reinforcement of 6 and 8 mm bar diameter used as control beams. The 12 beams are tested under static load at 4-point bending with a displacement control until failure. Different parameters have been used, such as lacing bar diameter 4, 6, and 8 mm, inclination angle of lacing bar 30, 45, and 60 degree with the beam axis, and lacing steel ratio, which is depending on the number of lacing bar in each longitudinal face, 1 or 2, and lacing bar diameter as shown in Figure 2. Conclusion: the mode of failure for all beams tested under static loading is a flexural failure mode. As shown in Figure A and B, we can see the failure of beams. Also in C and D, here in laced reinforced concrete beam with doubly and single lacing reinforced shear reinforcement in each longitudinal face. Also here we can see the failure in beams of laced reinforced concrete beams. Also we can see the failure of beams with lacing shear reinforcement. The first cracking load in beams tested under static loading is increased with increasing of lacing steel ratio and lacing bar diameter as shown in Table 1. We can see the comparison between the laced reinforced concrete beams with the reinforced concrete beam with the vertical shear reinforcement. We can see the increase in the first cracking load here. Also we can see in this column the comparison between the laced reinforced concrete beams between themselves with changing the lacing bar diameter and lacing steel ratio. The ultimate load of laced reinforced concrete beams is higher than the reinforced concrete beams. On the other hand, the deflection decreases. In addition, it is noticed that an additional increase in ultimate load and more dropping in deflection with increasing lacing steel ratio and lacing bar diameter, as listed in Table 2 and Figures 3 and 4. We can see here the comparison between beams with the vertical shear reinforcement and lacing shear reinforcement. This is the reference beam 6SRC and the reference beam for the comparison between beams with the vertical and lacing shear reinforcement with the bar diameter 8, and we can see in the last column the decreases in deflection as the same load level of reinforced concrete beams. This is here figure 3 and figure 4, the comparison between beams with the vertical shear reinforcement and lacing shear reinforcement. From the comparison results of laced reinforced concrete beams under static loading, it was noticed that the ultimate load is increased with increasing the diameter of lacing bar from 6 to 8, increasing lacing steel ratio, and using inclination angle of lacing bar 30 and 45 degree more than 60 degree as shown in Table 3. We can see here in the last two columns the increase in the ultimate load and the percentage of decrease in deflection. The comparison between laced reinforced concrete beams between themselves. And we can see in the last two row, the lacing inclination angle, the parameter type, we can see the increase in ultimate load and the decreases in deflection. The flexural steel reinforcement in laced reinforced concrete beams with a large lacing bar diameter and lacing steel ratio is characterized by resist yielding more than those beams with a small lacing bar diameter and lacing steel ratio under the effect of static loading as shown in figure 5 and 6. Thank you.